Hey geometry class, we're going to talk about a quick topic that does not require you to do anything but listen and follow along. So this is kind of a mini lesson in between your other lessons. Thank you for taking a look. I'm going to ask that you pay attention. So here we're going to talk about biconditional statements, and it's kind of an extension of section 2.3. So what's a biconditional statement? Sometimes biconditional statements are referred to as if and only if statements. So what it says here is that a biconditional statement is a conjunction of a conditional and its converse. So if you remember from the last section when we talked about the conditional would be like P implies some Q. Its converse would be that Q implies some P. And so we've got a conjunction, meaning and in this case. Both of these things are true, right? So it will be written as this double arrow situation here that we see, and it's read as P if and only if Q, and sometimes it's written as PIFF all right? Make it a Q, make it a Q. You get where I'm trying to go. So what is the purpose of this and what does it mean? Well, let's think of a situation where we could use it as, let's think of a situation that is biconditional. So how about this one? If I have no money, then I am broke, right? That's true. And then I could say it the other way. If I am broke, then I have no money. Both of these are true statements. And so this is the statement and this is the conditional. And then I can say, okay, well, both of these are true. If I have no money, then I am broke. If I am broke, then I have no money. So then I can say, I can then think of this as a biconditional statement and write it as an if and only if. So that would be, I have no money if and only if I am broke. Or I could say it the other way, I am broke if and only if I have no money. And I don't think you would have any problem agreeing that that statement is true, and that's a biconditional statement because both of them are necessary. Like one, you can't have one without the other. All right, so let's take a look at a couple of examples. We're told to write each biconditional statement as a conditional and its converse, then determine whether the biconditional is true or false, and give a counterexample. So let's take a look. An angle is a right angle if and only if its measure is 90 degrees. Stay focused on just this bold print line. An angle is a right angle if and only if its measure is 90 degrees. That sounds true to me. So let's think about, what does the conditional say? The conditional would be one way. If an angle is 90 degrees, then the angle is right. Flip it around for the converse. If an angle is right, then the angle is 90 degrees. I think we can see that both of these are true. The conditional and the converse are true. So the biconditional is true. Let's take a look at this guy. X is greater than -2 if and only if X is positive. X is greater than -2 if and only if X is positive. Understand the statement? Let's check out the conditional. So the conditional would just be one way, starting with this and going here. If X is, well, they started with this. If X is positive, then X is greater than -2. If X is positive, then X is greater than -2. That's true, right? If X is positive, it's got to be greater than -2. Let's check out the converse. If X is greater than -2, then X is positive. And I know your eyeballs are already down here saying, well, we can see it's false, old lady. And it is false because X could be -1. Check it out. X could be greater than -2 and still not positive. So the hypothesis of the converse can be true when the conclusion is false. Therefore, this part is not true, and therefore the biconditional itself is false. Is that making sense? The reason why I wanted to make sure and give you just a really quick lesson and talk about this is the fact that this is a real often point that comes up in mathematics, and you'll see if and only if statements, and somehow your text chose to place it as like this ancillary extension, and I thought it was worthy of a little bit more attention. You can pause this and use this as practice to see which ones come up to be true for you and which work out, and just to practice the concept. So I'm going to just give you a heads up on the answers. So if you don't want that, pause. But if you do, my heads up is this. This statement is true as a biconditional. This guy is false. Look for a counterexample. And so are these guys. All of these are false. And this, you're setting up a truth table. So that's not really necessary for me to do for you. All right. Thank you for paying attention to that. Let's get on to the next section.